My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Data Engineering with Python as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 5 first important short question is: what is the difference between descriptive statistics and inferential statistics? Difference between descriptive and inferential statistics. Descriptive statistics is used to summarize and describe the main features of data. It tells us what the data looks like using measures like mean, median, mode, range, and graphs. It does not make predictions or generalizations. Example: in a class of 50 students, finding the average marks of all students is descriptive statistics. Inferential statistics is used to make predictions or conclusions about a larger population based on a sample of data. It uses probability, hypothesis testing, and confidence intervals. Example: taking marks of 10 students and predicting the average marks of the entire class is inferential statistics. Feature descriptive statistics, inferential statistics. Purpose: summarize data, makes predictions and conclusions based on entire dataset sample of data. Example: average marks of all students predicting population average. Easy tip: descriptive is equal to describe data you have. Inferential is equal to infer about data you don't have. Next important short question is: 2. Define variance and standard deviation. Variance and standard deviation. Variance measures how far the data points are spread out from the mean average. It is the average of the squared differences from the mean. Formula: variance sigma 2 is equal to x mu to n, where x is equal to data points, mu is equal to mean, n is equal to number of data points. Standard deviation, SD, is the square root of variance. It shows how much the values deviate from the mean in the same unit as the data. Formula: standard deviation, sigma, is equal to variance. Example: if marks are 10, 20, 30, mean is equal to 20. Variance is equal to 66.67, SD 8.16. This means scores are spread around 8 marks from the mean. Easy tip: variance is equal to spread squared. SD is equal to real life spread. Next important short question is: 3. What is a decision tree in machine learning? Decision tree in machine learning. A decision tree is a simple and powerful tool used in machine learning for making decisions or predictions. It looks like a tree with nodes and branches. Root node, the starting point of the tree. Decision nodes, points where data is split based on conditions. Leaf nodes, final outcomes or predictions. It works like a step-by-step question game. At each node, a question is asked, like is age 18? Based on the answer, yes, no, data moves to the next branch until a decision is made. Example: if we are predicting if a person will buy a bike. 1. Check age 25. 2. Check income high-low. 3. Predict buy not buy. Why it's useful? Easy to understand and visualize. Works for classification, yes, no, and regression, numbers. Think of it like a flowchart for smart decisions. Next important short question is: 4. Write a short note on overfitting in machine learning models. Overfitting in machine learning. Overfitting happens when a machine learning model learns too much detail from the training data, including noise and errors, instead of just the important patterns. This makes the model perform very well on training data but poorly on new or test data. It's like a student memorizing answers instead of understanding concepts. They score well in mock tests but fail in real exams with different questions. Example: a decision tree that keeps splitting until it perfectly fits every training point may predict wrongly for new data because it became too complex. Causes: too many features, too complex models, deep trees, large neural networks. Not enough training data. Prevention: use simpler models. Apply cross-validation. Use regularization or dropout techniques. Think of overfitting as being too perfect on paper, but failing in reality. Next important short question is 5. What is the importance of clustering in data science? Importance of clustering in data science. Clustering is a technique in data science that groups similar data points together without labels. It helps us find hidden patterns and organize data naturally. Think of clustering like arranging your wardrobe. You put shirts together, trousers together, and shoes together. The computer does the same with data. Why it's important? Customer segmentation. Businesses can group customers by buying habits, example, budget versus luxury shoppers. Market research helps discover trends and new opportunities. Anomaly detection identifies unusual data like fraud detection in banking. Recommendation systems groups similar users or products for personalized suggestions. Image compression groups similar colors to reduce file size. Example: an e-commerce site clusters customers into frequent buyers, occasional shoppers, and window shoppers to send targeted offers. Clustering makes data easy to understand and is a powerful decision-making tool in almost every industry. Next unit we top 5 long questions. First important long question is: explain different probability distributions with examples and Python implementation. Probability distributions with examples and Python. A probability distribution shows how likely different outcomes are in an experiment. It can be discrete, specific values, or continuous, any value in a range. 1. Discrete distributions. A. Binomial distribution. Used when there are two possible outcomes, success-failure, repeated several times. Example: tossing a coin 5 times, probability of getting 3 heads. Python example. From cp.st import bino. N is equal to 5 hash trials. P is equal to 0.5 hash probability of success. K is equal to 3 hash number of successes. Prob is equal to bino.pmf, k, n, p. Print, prob, hash 0.3125. B. Poisson distribution. Models the number of events in a fixed interval. Example: cars passing a toll booth per hour. Python example. From cp.st import Poisson. Mu is equal to 4 hash average events. K is equal to 2. Prob is equal to Poisson.pmf, k, mu. Print, prob, hash 0.1465. 2. Continuous distributions. A. Normal Gaussian distribution. Most common distribution, data clusters around the mean. Example: heights of students in a class. Python example. From cp.st import non. Mean is equal to 170. STD is equal to 10. X is equal to 180. Prob is equal to non.pdf, x, mean, std. Print, prob, hash probability density at 180. B. Exponential distribution. Models time between events. Example, time between two buses arriving. Python example. From cp.st import expon. Scale is equal to 5 hash average time. X is equal to 3. Prob is equal to expon.pdf, x, scale is equal to scale. Print prob. Summary. Distribution type example. Binomial discrete coin toss. Poisson discrete cars per hour. Normal continuous heights, weights. Exponential continuous time between events. Easy tip. Discrete is equal to countable events. Continuous is equal to measurable values. Normal is equal to bell curve. Next important long question is: 2. Describe statistical measures, mean, median, mode, variance, standard deviation, and implement them in Python. Statistical measures with Python implementation. Statistical measures help us summarize and understand data. The most common measures are: 1. Mean, average. The sum of all values divided by the number of values. Example, marks is equal to 10, 20, 30, mean is equal to 10 plus 20 plus 30, 3 is equal to 20. Python. Data is equal to 10, 20, 30. Mean underscore value is equal to sum, data, lay, data. Print, mean underscore value, number 20. 2. Median. The middle value when data is sorted. If even number of values, median is equal to average of two middle values. Example, 10, 20, 30, 40, median is equal to 20 plus 30, 2 is equal to 25. Python. Data is equal to 10, 20, 30, 40. Data.sort. N is equal to lay, data. Median underscore value is equal to data n to 1 plus data n to 2. Print, median underscore value, number 25. 3. Mode. The value that appears most frequently in the dataset. Example, 10, 20, 20, 30, mode is equal to 20. Python. From statistics import mode. Data is equal to 10, 20, 20, 30. Print mode data. Number 20. 4. Variance. Measures how far data points are from the mean. Example, 10, 20, 30, mean is equal to 20, variance is equal to 10 to 20, superscript 2 plus, 20 to 20, superscript 2 plus, 30 to 20, superscript 2, 3 is equal to 66.67. Python. Data is equal to 10, 20, 30. Mean underscore value is equal to sum, data, lay, data. Variance is equal to sum, x, mean underscore value, asterisk asterisk 2 for x in data, lay, data. Print, variance, hash 66.67. 5. Standard deviation, SD. Square root of variance shows spread in the same unit as data. Example, SD is equal to 66.678.16. Python. Import math. std underscore dev is equal to math.sqrt variance. Print std underscore dev hash 8.16. Quick tips. Mean is equal to central value. Median is equal to middle value. Mode is equal to most frequent value. Variance and SD is equal to data spread. Memory tip, think mean is equal to balance, median is equal to middle, mode is equal to popular, SD is equal to wiggle. Next important long question is: 3. Explain how to design a predictive experiment in Python with an example. Designing a predictive experiment in Python. A predictive experiment in Python involves creating a model that can predict outcomes based on past data. It is widely used in data science for tasks like sales forecasting, stock prediction, or student performance analysis. Steps to design a predictive experiment. 1. Define the problem. Decide what you want to predict. Example, predict whether a student will pass or fail based on study hours and attendance. 2. Collect data. Gather past data related to the problem. Hash sample dataset. Data is equal to hours 2, 3, 5, 1, 4. Attendance 1, 0, 1, 0, 1. Result 0, 0, 1, 0, 1. Hash 1 is equal to pass, 0 is equal to fail. 3. Preprocess data. Clean the data, handle missing values, and split features x and target y. X is equal to 2, 1, 3, 0, 5, 1, 1, 0, 4, 1. Y is equal to 0, 0, 1, 0, 1. 4. Choose a model. Select a machine learning model, example, logistic regression for classification. From sklearn.linear_model import logistic regression. Model is equal to logistic regression. 5. Train the model. Fit the model to your data. Model.fit x, y. 6. Make predictions. Use the model to predict new outcomes. New_data is equal to 3, 1, number 3 hours, attended class. Prediction is equal to model.predict, new_data. Print, prediction, hash output, 1, pass. 7. Evaluate the model. Check accuracy using metrics like accuracy, confusion matrix, etc. From sklearn.metrics import accuracy_score. y_pred is equal to model.predict x. Print accuracy_score y_pred hash example accuracy. Key points to remember. Always define the problem clearly. Clean and preprocess data properly. Choose appropriate model based on prediction type. Evaluate results to ensure reliability. Memory tip: think of a predictive experiment as a smart guess based on past experience. Next important long question is 4. Discuss linear regression with an example and Python code. Linear regression in Python. Linear regression is a statistical technique used to predict a continuous outcome based on one or more input variables. It finds the best fit straight line that relates the inputs, x, to the output, y. The formula of a simple linear regression is y is equal to mx plus cy is equal to mx plus c, where y is equal to predicted value, x is equal to input feature, m is equal to slope of the line, c is equal to intercept. Example, predicting marks based on study hours. Suppose we have data of students' study hours and their marks. Hours marks 240, 350, 570, 130, 460. We want to predict marks for a student who studies 6 hours. Python implementation. Hash import libraries. From sklearn.linear_model import linear regression. Import numpy as np. Hash data. X is equal to np.array 2, 3, 5, 1, 4 hash study hours. Y is equal to np.array 40, 50, 70, 30, 60 hash marks. Hash create model. Model is equal to linear regression. Model.fit x, y. Hash predict marks for 6 hours. New_data is equal to np.array 6. Prediction is equal to model.predict new_data. Print prediction hash output 80. Explanation. 1. Import libraries sklearn for model, numpy for data arrays. 2. Prepare data, x is equal to input, hours, y is equal to output, marks. 3. Create and train model, model.fit, x, y, finds the best fit line. 4. Predict, model.predict, gives estimated marks. Key points. Simple linear regression has one input, multiple regression has many inputs. Works best when there is a linear relationship between input and output. Easy to implement and understand, widely used in sales prediction, student performance, stock prices, etc. Memory tip: think of linear regression as drawing a straight line through data points to make smart predictions. Next important long question is 5. Explain k-means clustering and random forest algorithm with suitable examples. K-means clustering and random forest in Python. 1. K-means clustering. K-means is an unsupervised learning algorithm used to group similar data points into clusters. You choose the number of clusters, k, and the algorithm organizes the data so that points in the same cluster are closer to each other. Example: segmenting customers based on their spending habits. Python implementation. From sklearn.cl uster import k-means. Import numpy as np. Hash sample data, age, spending score. Data is equal to np.array, 25, 60, 30, 70, 22, 50, 35, 80, 40, 20, 45, 25. Hash create k-means model with two clusters. Means is equal to k-means, n underscore clusters is equal to 2, random underscore state is equal to 0. Means dot fit data. Hash cluster labels. Print means dot labels underscore. Hash output 111100. Hash predict cluster for a new customer. Print means dot predict 28, 65. Hash output 1. Key point: k-means helps find patterns in data without labels. 2. Random forest algorithm. Random forest is a supervised learning algorithm used for classification and regression. It works by creating many decision trees and combining their results for better accuracy. Think of it as a forest of trees voting for the best outcome. Example: predict whether a student will pass or fail based on study hours and attendance. Python implementation. From sklearn.ensemble import random forest classifier. Hash sample data, hours, attendance. X is equal to 2, 1, 3, 0, 5, 1, 1, 0, 4, 1. Y is equal to 0, 0, 1, 0, 1. Hash 0 is equal to fail, 1 is equal to pass. Hash create random forest model. Model is equal to random forest classifier, n underscore estimators is equal to 5, random underscore state is equal to 0. Model.fit x, y. Hash predict new student. Print model.predict 3, 1, hash output 1, pass. Key point: random forest reduces errors by averaging multiple trees, making it robust and accurate. Summary. Algorithm type use case. K-means clustering unsupervised customer segmentation. Random forest supervised classification and regression. Memory tip. K-means is equal to grouping similar things. Random forest is equal to many decision trees voting together.